If you think about it, smart contracts are a lot like people in a social network. By itself, a single contract is, well, it's just a lonely piece of code. But the real power, the magic that makes all of DeFi and Web3 actually work, that only happens when they start talking to each other. So the big question is, how does that actually happen? I mean, think about it. If one contract needs to check your token balance in another one, or maybe a lending protocol has to ping a stablecoin contract, how do they have that conversation on the blockchain? Well, that's exactly what we're going to dive into right now. So the most common way, and honestly by far the safest way for contracts to interact, is through something you can think of as a formal professional handshake. And in the world of Solidity, which is the main programming language for Ethereum, we call this an interface. The brilliance of an interface is just how simple it is. Seriously, it's just like a restaurant menu for a smart contract. It lays out all the public functions you can call, the what, but it doesn't get bogged down in all the messy code of how those functions actually work behind the scenes. This creates a super predictable and, most importantly, a reliable way for contracts to interact with each other. Okay, so this slide really gets to the heart of why this matters. See, on one hand, you could just try to call a contract using its address directly. But that's kind of like shouting into a dark room and just hoping the right person answers. The compiler has no way to check if you made a typo or got the function name wrong. But using an interface, that's the best practice. Why? Because the compiler verifies everything for you. It's like having a built-in safety net that makes absolutely sure you're calling the right function the right way every single time. And if you want a perfect example, look no further. This right here might be the most famous interface in all of crypto, IREC20. This simple set of rules is the universal standard for pretty much every token on Ethereum. It's the reason any wallet, any exchange, any DApp automatically knows how to check a token's balance or how to transfer it, no matter how that token was built. This is what makes the entire DeFi ecosystem work together so seamlessly. All right, so interfaces are the nice, safe, polished way for contracts to talk. But what if you need more control? What if you're an expert and you need to get your hands dirty and talk directly to another contract's engine? Well, for that, we've got to go under the hood and look at low-level calls. And right away, I have to give you a huge warning. These low-level calls, we're talking call, static call, and delegate call, they are unbelievably powerful, but they bypass a lot of the safety checks we just talked about with interfaces. So they give you maximum flexibility, but they demand absolute precision from you, the developer. One tiny mistake here can lead to, well, catastrophic consequences. This table does a great job of breaking down the differences. Let's start with call. Think of this as your general purpose tool. It can go in and actually change the state of the contract it's calling. Now, look at static call. The key difference? It's read-only. It can't make any state changes, which makes it the perfect, safe way to just read data from another contract. And then we have delegate call. This one is the most powerful and frankly the most dangerous. It lets a contract execute code from another contract, but, and this is the absolute crucial difference you see highlighted there, it runs that code within the context of the caller's storage. This is the secret sauce behind upgradable contracts, but man, it also opens the door to really serious risks like storage collisions if you don't know exactly what you're doing. So you might be wondering, how do these low-level calls actually work? Well, you have to build the message, or what we call the payload, completely by hand. It's basically a two-step process. First, you have to figure out the function selector. That's a unique 4-byte ID that tells the target contract which function you want to run. Then, step 2, you have to pack all the arguments, all the data that function needs, into a byte array. You are literally handcrafting the raw data packet that the Ethereum virtual machine will execute. Pretty low-level stuff. Okay, so far, we've been talking all about how contracts talk to other contracts. But the blockchain isn't some sealed-off little box, right? Smart contracts have to communicate with the outside world. And that's where two other key concepts come into play: events and oracles. I love this analogy because it makes it so clear. Think of events as the contract shouting out to the world. So when a token transfer happens, the contract emits a transfer event. Now, this isn't for other contracts on the chain to hear. It's basically a log, a signal, for off-chain applications like the front end of your favorite DApp or your wallet to listen for and react to. Oracles do the exact opposite. They are the listening in part. They're the bridge that lets a contract ask for and pull in critical information from the real world, like what's the current price of ETH. And really, this is why oracles are so incredibly important. I mean, without them, a DeFi lending protocol would be flying blind. It would have no idea what the price of an asset is. An insurance contract couldn't check the weather. Oracles are that secure bridge that makes smart contracts actually relevant and responsive to what's happening in the real world. All right, we've covered a lot of different communication methods here, and it's really important that you don't see these as like competing options. The best way to think about this is as a developer's toolkit, where each tool is designed for a very specific job. So let's wrap it up with a quick guide. Your go-to, your default for safe and predictable calls, that's interfaces. When you need to interact with a contract but you don't know what it is ahead of time, you'll use call, but you'll use it with caution. For safely just reading data without any risk of changing things, you'll grab static call. For the really advanced stuff, like building upgradable proxies, that's where the power tool delegate call comes in. But again, it's extremely risky. And finally, to connect your contract to the off-chain world, that's the job of events and oracles. It's all about knowing your toolkit and picking the right one for the job. And all of this leads to a final, and I think pretty crucial question. We spend so much time and energy focusing on securing the code inside a single smart contract. But as this whole ecosystem gets more and more interconnected, as DeFi becomes this massive tangled web of conversations, maybe the biggest challenge moving forward isn't just building secure contracts, but securing the conversations between them.